Hey everyone, and welcome to this explainer. Today, we are going to do something really exciting. We're going to transform a totally fresh Ubuntu 26.04 LTS installation into a dedicated, professional-grade cybersecurity workstation. We're talking a setup built for ethical hacking, penetration testing, and hardcore blue team operations. I'm absolutely thrilled to walk you through this, because honestly, your operating system, it's your primary weapon. Whether your goal is to be an ethical hacker on the red team actively breaking into systems, a blue team engineer defending those networks, or a SOC analyst trying to make sense of the digital chaos, building a rock-solid environment is literally step one. Now you might be wondering, why Ubuntu? Well, it's pretty much the undisputed industry standard for Linux engineering and security operations. But here's the thing, a standard out-of-the-box OS just isn't going to cut it for what we do. Professionals build dedicated, highly isolated workstations so their main host machines remain clean, fast, and most importantly, secure. So today, you're going to learn exactly how to build that elite setup yourself. Okay, let's quickly look at our blueprint for today. We're going to tackle this in 5 phases. First up, the Cyber Workstation Foundation. Then, environments and network visibility. After that, we'll dive into the offensive security arsenal, followed by defensive operations and hardening. And finally, we'll map out your cybersecurity learning journey. Let's jump right in.
Starting with Section 1, the Cyber Workstation Foundation, we have to establish a secure, organized baseline first, because think about it, you simply cannot defend a network from a machine that is itself vulnerable. The foundation is absolutely everything.
So, the professional vision for 2026 is all about isolation and modern security features. Professionals isolate their tools on dedicated systems. Why? To keep their everyday host machines completely clean. By leveraging Ubuntu's TPM-backed full disk encryption, you're basically guaranteeing that even if someone physically steals your laptop, your sensitive vulnerability data stays completely locked away. It's like a digital vault. Plus, we're relying on memory-safe Rust core utils now, which is a real game changer. It makes the system inherently immune to entire classes of buffer overflow attacks, right at the OS level. No way attackers are getting in through those legacy bugs anymore.
All right, so phase 1 is actually getting our hands dirty. We kick things off by patching the system with a standard sudo apt update and upgrade to ensure we have the absolute latest security patches. You never want to start with a vulnerable baseline. Next up, we install what I call the Linux Survival Kit. We're pulling in curl and wget, which you'll use constantly for downloading payloads or scripts straight from the web. We grab htop to keep an eye on CPU spikes, especially during heavy brute force attacks. And you absolutely 100% need tmux. It's a terminal multiplexer, which is basically essential for running, say, a reverse shell in one pane while managing a local listener in another, all in the same window. These tools are literally the oxygen of the command line. Oh, and we also install Git here and configure our global username and email. That's critical for pulling down open source security repositories from GitHub later on.
Now, moving on to phase 2, and this is where we make the terminal actually work for us. We want to reduce cognitive friction, right? You shouldn't be fighting your terminal. So we replace the default bash shell with ZSH. When you pair that with a framework like OhmyZSH, you get incredible productivity boosts, visual Git statuses, themes, auto-completion, and some really powerful aliases. Next, we equip our core programming languages, setting them up in isolated virtual environments. Python is pretty much the undisputed king of custom exploit development. Go is what you want for writing lightning-fast networking tools. And JavaScript? You need it to really understand modern web app vulnerabilities. Finally, we set up Visual Studio Code as our main command center. We load it up with security auditing extensions like GitLens and Akito Security so we can actually catch vulnerabilities in our own scripts before they ever go live.
Okay, this next part is vital. A disorganized hacker is an ineffective hacker. It's that simple. So we use the mkdirp command to build out a master CyberLab directory structure. We're talking dedicated folders for notes, reports, scripts, logs, you name it. If you don't organize these from day one, you are going to lose your exploit code or, actually scratch that. Worse, you might mix up client data during a live penetration test, which is a massive professional failure. We pair this structure with a few key tools. We use Obsidian for note-taking because it builds a localized, markdown-based knowledge graph. It's essentially your own personal cybersecurity wiki that doesn't rely on the cloud at all, keeping your data yours. For web research, we use the Brave browser for privacy, without all the trackers. And for documentation, Flameshot is hands down the absolute best screenshot tool for Linux. It lets you draw arrows and annotate evidence right on the fly, which is a lifesaver for writing up those penetration testing reports later.
Moving on to Section 2, Environments and Network Visibility. We need safe, contained sandboxes for running dangerous code because you should literally never test malware on your primary file system. Plus, you can't hack or defend what you can't actually see. In cybersecurity, isolated environments are non-negotiable, and we basically have two main ways to do this. We use Docker containers, which act like lightweight shipping containers for super rapid tool deployments. And then we have virtual machines, which are more like separate apartments with their own walls providing heavy-duty hardware isolation. Docker is just incredible for this work. With Docker Compose, you can spin up entirely reproducible, isolated labs or intentionally vulnerable web apps in seconds. But virtual machines, using software like VirtualBox, let us run completely different operating systems on our machine. Think Kali Linux for an all-in-one attack box, Windows for practicing Active Directory attacks, or Metasploitable just for target practice.
Let's look at the numbers to put this into perspective. This data paints a really clear picture of why, as a beginner, you absolutely need both. Look at the startup times. Docker spins up your security tools in just about 3 seconds, with a tiny 6 to 8 megabytes of memory overhead. That makes it perfect for rapid, throwaway tool labs. Meanwhile, virtual machines are going to take a few minutes to boot and eat up gigabytes of RAM. But that trade-off gives you strict, hardware-level isolation. You need that heavy-duty wall for safe, deep malware analysis. Plus, with VMs, you'll constantly be using snapshots. Snapshots let you save the exact, perfect state of a machine right before you intentionally nuke it with an exploit.
All right, let's talk about actually seeing the network. To achieve true network intelligence, we equip some legendary tools. Nmap is our cartographer. It maps out live hosts and exposed ports so we know what we're looking at. Wireshark and tcpdump are basically our command line and GUI microscopes. They let us capture and visually inspect every single packet flowing through our network interface. Dig is our go-to for figuring out DNS routing. And then there's Netcat. Netcat is the ultimate Swiss Army knife for networking. You can read and write data across raw connections, and it's most frequently used by professionals to catch incoming reverse shells. If you're a beginner, mastering these tools isn't optional, it's the whole ballgame.
Which brings us to Section 3, the Offensive Security Arsenal. Now that we can see the network, it's time to transition into configuring our Red Team toolkit to actively probe and penetrate those defenses. Now, before we launch any exploits, we have to talk about reconnaissance. The absolute crucial point, rule number 1 of mapping a target, is that you must always conduct passive reconnaissance before you make any noise with active reconnaissance. If you go loud too early by blasting a server with automated scanners, a good SOC analyst is going to spot you immediately, block your IP, and boom, your engagement is over before it even begins. So we start stealthy. We use tools like AMAS, Subfinder, and the Harvester. These tools act passively. They scrape third-party databases, search engines, and public records for subdomains and employee emails without ever directly touching or alerting the target's actual servers. It's like gathering intelligence from across the street. Only once we have that full map do we decide to go loud. That's when we pull out tools like FUF and GoBuster to aggressively brute force the web servers. We're talking firing thousands of requests a second to uncover hidden admin panels or expose configuration files that the admins thought were secret.
Next up in our active arsenal, we configure Burp Suite Community Edition and OWASP Zap. These are intercepting web proxies. Basically, they sit right between your browser and the target server, allowing you to pause, deeply inspect, and even rewrite web requests on the fly. It's an absolute must-have for testing web application security. For password auditing, we install Hashcat and John the Ripper. These tools will utilize your CPU and GPU to crack stolen password hashes against massive word lists. And for the wireless side of things, we install Aircrack-ng to monitor traffic and crack Wi-Fi handshakes. But listen to me very carefully right now. You must strictly use these tools only on networks you own or environments where you have explicit written authorization to test.
We are professionals here, and staying legal is 100% non-negotiable.
Once the network is fully understood and mapped, we scan it for known weaknesses. We do this at a few levels. Locally, we run Lynis. Lynis gives us a hardening index score and points out weak Linux configurations right on our own box. For web servers, we point Nikto at them for lightning-fast checks against dangerous, outdated files. And then, stepping up to the enterprise level, we spin up OpenVAS. OpenVAS is an enterprise-grade network vulnerability scanner that can scan entire corporate subnets and generate massive compliance reports. For beginners, I highly recommend installing OpenVAS inside a Docker container, just to get a feel for how automated large-scale enterprise scanning actually functions in the real world. All right, Section 4, Defensive Operations and Hardening. Time to flip the script entirely to the blue team perspective. We're going to look at how to catch the hackers we just were and how to harden this exact Ubuntu workstation into an absolute fortress. Because everything we just learned how to attack, we now have to understand how to defend.
To detect threats, like those loud brute force attacks we talked about, in real time, we set up Wazuh and the Elastic Stack. Wazuh is an open-source SIEM. That stands for Security Information and Event Management, and it's also an XDR, meaning Extended Detection and Response. Think of it as a giant, intelligent security camera system for your network. It collects logs from every endpoint, performs file integrity monitoring to tell you if an attacker secretly modified a sensitive system file, and alerts you instantly. Because SIEMs generate and manage massive amounts of compliance data, we back it up with PostgreSQL as our database, and we use DBeaver Community Edition to visually query and manage that data. Now, Wazuh is a complex beast with a lot of moving parts, so I'm actually going to be doing a dedicated, full tutorial just on that installation in the future.
Next, we actively secure our newly built workstation. We start by enabling the UWF, the uncomplicated firewall, and setting it to explicitly deny all incoming traffic by default. Then, we install a brilliant little automated defense tool called Fail2Ban. If an attacker tries to guess your SSH password and fails 5 times, Fail2Ban automatically updates the firewall to block their IP address. We combine these defenses with sysec kernel hardening, like enabling SYN cookies to prevent denial-of-service attacks. We also enforce strict SSH key authentication rather than passwords, and we make sure we are always operating on the principle of least privilege.
Now, this slide brilliantly illustrates a huge, common beginner pitfall. You have to pay attention here. By default, Docker actually bypasses UFW. Because container ports require manual local binding, your isolated Docker tools might be completely exposed to the web, even if you think your firewall is locked down. This happens because Docker manipulates IP tables directly, essentially routing traffic right around UFW. So if you spin up a vulnerable web app container for testing and you don't explicitly bind it only to your local host, congratulations! Your secure workstation just became an open, vulnerable target for anyone on your local network. Always bind to localhost.
And finally, Section 5, your cybersecurity learning journey. Your ultimate workstation is now built, patched, and secured. But remember this, all these tools we just installed, they are completely useless without the foundational knowledge to wield them. Having a shiny wrench doesn't magically make you a master mechanic, right?
So this roadmap right here dictates your exact next steps. You need to master Linux fundamentals and networking first. Only then should you advance into scripting with Python, containerization with Docker, packet analysis with Wireshark, mapping with Nmap, and eventually tackling complex CMs like Wazuh or going for professional certifications. Please, do not rush straight to the sexy hacking tools. If you don't understand how TCP/IP actually works under the hood or how DNS resolves a hostname, you won't have any idea why your exploit just failed. Learn the command line deeply, understand how packets move across the wire, and learn to automate your tasks.
I recommend progressing systematically through these phases. Spend your first few months just living in the fundamentals, Linux and networking. Then move on to scripting and mastering your core tools. By months 7 through 9, you should be legally practicing in Capture the Flag environments, or CTFs, testing your skills against intentionally vulnerable boxes. From there, you can start aiming for enterprise-level detection engineering and finally, wrap up your first year by going after those professional certifications that will actually help you land the job.
And there we have it. You now have a professional, isolated, and highly capable Ubuntu workstation that is ready for any red or blue team task you throw at it. As we wrap up this explainer, I want to hear from you. Drop a comment below with the specific tool you want to master next. Make sure to subscribe because we have upcoming full step-by-step installation guides on Wazuh, Burp Suite, OpenVAS, and more. Until then, take a hard look at your current operating system and ask yourself, is your workstation truly ready to defend against the threats of 2026, or are you already a target? Keep learning, stay safe, and I'll see you in the next one.